Hello there. Welcome to another episode of Navigating Uncertainty. In this episode, we are going to be talking about an interesting development in Industry 4.0, smart factories. So, before we explore smart factories, let's first explore the traditional manufacturing factory. Traditional factories came into existence in the 18th century, but as the years rolled on, traditional factories often evolved slowly and have the following inherited characteristics. Manual processes. Traditional factories heavily relied on human labor for operation, monitoring, and decision-making. There was hardly any automation, and machines were often standalone and task-specific. Linear and siloed systems. Operations function in isolated departments such as production, logistics, and quality. There was hardly integration and communication between people and systems. Reactive maintenance. Equipment was often fixed after failures occur, which led to unexpected downtime. There was a lack of predictive tools or real-time monitoring to understand what was going on at the grassroots level. Low data visibility. Data collection was manual or based on spreadsheets such as Microsoft Excel. Minimal real-time data and decisions were made based on historical trends or gut feeling. Limited flexibility. It was difficult to switch product lines or respond quickly to changing demand. Customization and small batch production were inefficient. High waste and low efficiency. Lack of optimization tools led to excess materials, energy use, and time. Lean principles might have been in place, but it was often not data-driven. Quality control. Quality control was often done after production instead of during, and often resulted in higher defect rates and rework costs. So, let's fast forward to 2025. Does the same traditional manufacturing factory model work? What needs to change? Why? Let's explore. Demand for real-time decision-making. We live in one of the greatest eras of humanity with technological breakthroughs happening every single day, and it's getting faster with time. But it also has created this massive uncertainty for both businesses and consumers to adapt, evolve, and thrive. Global supply chains and fast-changing markets require instant responsiveness, and the traditional manufacturing factory isn't able to cater towards it. We need a new model which enables real-time monitoring and autonomous decision-making to keep up with the changes happening in the world. Need for efficiency and sustainability. Factors such as rising energy costs, material waste, and ESG, environmental, social, and governance, pressures demand leaner and greener operations. Manufacturing is often considered to have a high carbon footprint, but that needs to be changed for the better. Workforce challenges. Aging workforce and skills gaps are pressuring manufacturers to automate and augment human roles. Downtime is expensive. Unplanned downtime often leads to a severe negative impact to production. This is true especially in mission-critical scenarios in which meeting deadlines and targets is a must. Data is the new oil. In traditional manufacturing factories, data is often underutilized. This underutilized data often contains hidden gems which manufacturers can use to create their blue ocean strategy and make competition irrelevant. Global competition. Businesses aren't just competing in their home turf anymore. It's a global battle for domination. So, all these challenges led to the birth of the smart factory. Well, in simple terms, a smart factory is a highly digitized and connected production facility which uses technologies such as artificial intelligence, AI, machine learning, ML, Internet of Things, IoT, robotics, and real-time data to self-optimize performance, predict issues, and adapt to changing conditions, all with minimal human intervention. Automation and execution. Technologies such as industrial robots, cobots, programmable logic controllers, PLCs, computer numerical control, CNC, machines, automated guided vehicles, AGVs, autonomous mobile robots, AMRs, 3D printing, Additive manufacturing and machine vision systems enable the automation and execution component of a smart factory. Perception and sensing. In a smart factory, it is important to know what is happening in real time, and technologies such as smart sensors, temperature, vibration, humidity, etc., RFID and barcode scanners, computer vision cameras, audio and acoustic sensors, environmental monitoring systems make it happen. Integration and interoperability. Smart factories are an ecosystem. There are different systems which talk to each other and create that perfect blend and harmony. Technologies such as manufacturing execution systems, MES, enterprise resource planning, ERP, product lifecycle management, PLM, supply chain management, SCM, and application programming interfaces, APIs, enable seamless integration and interoperability within a smart factory. Intelligence feedback loops and continuous improvement. Then there's the intelligence component, which focuses on repairing, healing, and taking proactive steps to ensure that smart factories are operational. These technologies include real-time monitoring and feedback systems, self-healing systems, predictive and prescriptive maintenance, quality analytics tools, and OEE, overall equipment effectiveness, tracking to ensure issues within a smart factory are addressed instantly before they spiral out of control. Infrastructure and hardware backbone. None of the above technologies would have been possible without the underlying infrastructure and hardware backbone. These technologies include smart factory floor layout and sensors, edge servers and industrial PCs, smart grids, energy management systems, heating, ventilation and air conditioning, HVAC, and environmental controls and facility access systems make smart factories running smoothly. If you've read the above characteristics of a smart factory, it can be seen as complex. But the outcome is simple. Keep the factory running no matter what. It's actually quite similar to the way our human bodies work, and there are some stark similarities between a smart factory and a human body. So now let's explore how a smart factory is similar to the functions of the human body. Brain. Technologies such as artificial intelligence and machine learning are similar to the human brain. They help the smart factory to think, make decisions, and learn from patterns. Imagination. Computer simulation is like our imagination. Just like we can let our imagination run wild, we can also let computer simulation run wild and test different scenarios and see how the smart factory would behave and adapt. Memory. Big data and analytics are like our brain, helping to store data and also helping us to find hidden patterns and insights, just like neurons forming new connections. Intuition. Quantum computing helps us to do things that our rational brain never could. Quantum computing is similar to human intuition, as it helps us to process vast amounts of information and identify patterns that might not be immediately obvious. Quite similar to the times where we just know something without being able to explain why. Eyes and ears. Just like our eyes and ears help to enrich information already in our brain, AR and VR technologies overlays digital information onto what you're already seeing and hearing. In a smart factory context, workers wearing AR/VR headsets might need to see instructions or data about a machine while they're working on it. Sensory organs. Sensory organs such as eyes, cameras, visual sensors, ears, microphone, acoustic sensors, skin, touch sensors, pressure sensors, nose, gas sensors, chemical sensors, tongue, chemical sensors, taste sensors, internal sensors, environmental machine sensors, get data from both the internal and external environments. Nervous system. Just like the human body uses sensory neurons to gather information from the body, IoT devices collect data. The human nervous system transmits signals through a network of nerves to the brain, and so does IoT devices, which transmit data through a network to a central processing system or cloud platform, or to the edge computing. Muscles and bones. Just like muscles and bones help us to move around and do things, robotics and automation helps the smart factory to build things. Reflexes. Have you ever got burnt and you instantly took your hand away from the fire or hot pot without thinking? That's the power of reflexes. Similarly, robotic process automation, RPA, helps smart factories run tasks and operations without the need for human intervention. It can act based on the scenario or conditions which are set or even learn and then adapt and evolve with time. Our ability to heal. If you had a wound and got injured, your body has the amazing power to heal, recover, and restore. 3D printing helps to restore broken down components in smart factories, just like our body can heal and restore. Circulatory system. Just like the circulatory system transports oxygen, nutrients to different organs and transports waste back. Technologies such as 5G Wi-Fi 6, Wi-Fi 7 enable seamless communication between different processes, systems, and people. Immune system. Our immune system fights against pathogens including bacteria and viruses. In the same manner, cybersecurity components keep the smart factory safe. Legs. Just like our legs help us to move around, autonomous vehicles and drones support mobility within the smart factory, transporting resources, increasing efficiency and productivity. Body's building blocks, cells. Advanced materials are like the cells of the human body. Each has its own specific function and characteristics. Want to learn more about how smart factories are helping to build resilient businesses? Scan the QR code or click the link in the description to learn more. I'll see you in our next edition of Navigating Uncertainty.